Okay, I'm recording. So what we're going to cover is we're going to cover access control lists today. Now, to let me get a kind of starting point, have you covered any access control lists at all as you've gone through your HND?
Standard one.
A standard one, okay, right, that's a starting point. That's good, that's a good starting point. That's what I'm going to cover first. I'll cover standard access control lists, then I'll go into extended, then I'll go into named, and I'm going to cover IPv6 as well. So basically the premise of an access control list is to prevent access. It's an access control list. It's like a gatekeeper, if you like. It's to prevent access to a certain resource. I always try to simplify it and think about it like a bouncer at a nightclub. Bouncer says you're not getting in, you're not getting in. If the router's got an access control list that says your name's not in the list, then you're not coming in. That kind of idea. With a standard access control list, what you can do is you can block certain people from accessing your network. Now, with a standard access control list, let's say, for example, can you see the laptop up at the top left here, just where I've got my mouse, 10002 laptop? Let's say we wanted to block that laptop from getting to this server here, which is 192.168.0.2, the server over at the top right. Now, if we wanted to block him getting to there using a standard access control list, we would have to place the access control list here on the London router on this gigabit 00 port, and we would have to place it in the outbound direction because the traffic will be going out of the router towards there. That's where we've got to check it. So with a standard access control list, we're very, very limited in what we can do. We can only block a source IP address. So we have to block it nearest the destination. Now that's, straight away, that's got big downsides, hasn't it? Because if you think about this traffic here, this laptop is going to send traffic through the switch, through this router, across that serial link, across this serial link, get to here, and then it gets blocked. So the data's travelled all that way before it says, no, you're not coming in. And if it keeps sending data, if it keeps sending packets, then it's going to tie up that network, you know, or it's not going to tie it up, but it's going to add data onto that network that shouldn't really be there. And it's only when it gets to its destination point that it's being told, no, you can't get in. So you're wasting a lot of bandwidth by doing it that way. So that's a big, big downside of a standard access control list. The other thing about a standard access control list is you either block the person or you block the IP address or you permit it. That's it. You've got no, you can't fine tune it at all. So you can't say, well, I only want to block the laptop getting to this server. I only want to block web access, or I only want to block FTP access. You can't do that with a standard. You only block just the host itself. It's the whole thing. So, or a range of IP addresses you can block as well. But that's it. You either block the IP address, or you block the range of IP addresses, or the whole subnet of IP addresses, or you don't. There's no granularity about it. There's no fine tuning about it at all, and it's probably not the best option to use. One, because you're allowing data to go right from the laptop right across the network before it gets blocked, because it has to be placed nearest the destination. And you can't really fine tune it. You can't block ports, you can't block it based on protocol, none of that kind of stuff. However, they are easy to set up. And what I'll do is I'll just remind you how we can set up a standard access control list. So let's say, for example, we did want to block the laptop getting to the server. We would have to place it on the gigabit port, and we have to place it with the traffic going on an outbound direction. So it's checking packets that are leaving that port rather than packets going in. So remember, the in-out direction part is based upon imagining you sitting inside the router itself. Okay, so we'll go into the router, we'll go into command line, and we'll quickly set up this access control list and apply it. So to global config mode. So what we're going to do is we are going to block 10.0.0.2 from getting to this server. So basically we're blocking 10.0.0.2 coming in the outbound direction. Now, what we want to do is we want to say access list 1. Now, a standard access control list is anything between 1 and 99, the numbers of it. So if you're 1 to 99, automatically you have a standard access control list. Now what we're going to do is we're going to deny the 10.0.0.2 from getting basically out. Now what we want to do now is we have to now give it a wildcard mask. Now you remember what the wildcard masks are, yeah? It's basically, it's kind of like a subnet mask in reverse, if you think about it. But basically with a wildcard mask, a 0 means that you look at, and I always think like a 0 is like this, so you look at, and a 1 means you ignore, and I think of a 1 like an I for ignore. So basically we want to match that, so we want to make it like that. Oh, help if I could spell. I put in demi instead of deny. There we go. Now, if I then apply this to a port, what do you think is going to happen? Anyone? I'll stun you into silence. Okay, if I apply this to the gigabit port, what's going to happen? If I apply that access list 1, deny 10.0.0.2, 0.0.0.0, which basically means look at all of these. So I look at that, look at that, look at that, look at that. So you're going to match the whole address. So we're denying that address, and we're going to apply it to the gigabit port on the outbound direction. What's going to happen?
Is this going to stop this traffic from this IP address?
That's right. What happens if 10.0.0.3 traverses the network? So if I could move this out of the way. Just...
Yeah, it's allowed.
Are you sure? Only reason I say this is because a lot of people forget about the implicit deny. Now, in every access control list, there is what's called an implicit deny. So it's a statement that effectively says access list 1, deny everything. Okay, it's called an implicit deny because it's not there. It doesn't show it. It's implicit. It's just assumed that if you're going to run an access control list, you have to tell it what you want to deny, but you also have to tell it what do you want to permit, or else it will deny everything. So if you've only got one statement in your access control list and it's a deny statement, everything's going to be denied out of that port. So it's always worth remembering that with any access list, so access list 1 permit, and what you can do is you can do this. So basically you're saying 0.0.0.0, 0.0.0.0. What you can do instead, and what it will shorten it to, is just any. So if I just do permit any, that will allow anything else to go through. So now, if we apply that access control list, 10.0.0.3 will go through. It will be allowed. So that's us created an access control list. It won't start doing anything yet because we haven't applied it to the port yet. And I think the best way to show you that is if I get two screens up, what I'll do is I will start a ping, a kind of endless ping that will just ping, keep going and keep going and keep going. And you can see that going through the screen. And then I'll apply it to the port. And once I apply it to the port, you'll see the ping will start up to be, well, the ping will be stopped, won't it? It'll just say timed out, timed out, timed out. So let's start that process. So the access control list has been written. That's fine. It's ready to go. It's almost like writing a piece of software. You've written it, but you haven't run it yet, i.e. you haven't applied it to a port yet. So let me just start off. So if I do ping -t 192.168.0.2, what that should do is it should start pinging the server. There we go. First one times out because of ARP, remember? So it's happy. It's pinging away, no bother. Okay. Now what I'm going to do is pull back up my London router. And what we're going to do now is we're going to apply this to the port. So it's interface gigabit 00. And what we want to do is we say, we don't say apply access list or anything like that. What you say is IP access group 1 in. So we're basically saying it's an IP access group. It's not any other kind of protocol. It's an IP one. It's an access group. It's access group number 1 because that ties in with this number here. And no, it's not inbound, is it? It's outbound. I'm going to say it's on the outbound traffic. It's going to check the traffic coming out of that port. So it's traffic, coming out of the router towards the server. So as soon as I hit this, what you're going to start seeing is you're going to start seeing the replies being blocked. Okay, so I'm going to hit enter. There we go. See how quick that was? As soon as I hit that IP access group 1 out, boom, it stopped it. Okay, how do you turn an access group off? You just put no in front of it. Watch again. I'm just going to hit enter now. Can you see the pings coming back? So as soon as you hit that, straight away, that's it. It's applied. And I think that's a really good way to show how access lists actually work. Okay, so I'll stop that ping. You can see it. Well, I'll do it once more just to show you. So there's access group 1 out. Hit enter. Straight away, destination host unreachable. Can't get it. And switch it back off. Enter. There we go. Literally straight away. Straight away. So that's a standard access control list. Now, the things to remember about a standard access control list is you can, I'll stop that. With a standard access control list, the number is 1 to 99. So this number here, anything between 1 and 99 means that you're intending to use a standard access control list. Standard access control lists, you have to block nearest the destination because you can only block it based on source address. Now, it doesn't have to be just an IP address. It can be a range of addresses. So for example, if I said, right, I want to block any traffic coming from the 10 network, well, I can do that. So what I can do is, if I say no access list 1, right, that just deletes it, it's gone. What I can say now is IP access list 1 Oh. Damn it. Access list. Oh, come on, Ian. Access list 1. So what I want to do, I want to block the 10 range. So I want to deny 10.0.0.0. And this time, the wildcard mask is going to be 0.255.255.255. So what is happening this time is, I've just said the 10 network, because all I'm really caring about is I just want to get it to look for anything starting with 10. So what happens is here, I've said 10.0.0.0, and in the wildcard mask, I've said look at the first octet, but don't care about the other 3 octets. And so what will happen is anything matching a 10 is going to be blocked. And then what do we have to do? Access list 1, permit any to allow everything else, obviously, to go through. Now, if I go to my laptop here, my laptop, and I'll start pinging, you can see it's working. I'll go to the London, I'll go to interface gigabit 01, I'll apply it. Should have it here. There we go. And where's my
0.0?
Oh, was it 00? Oh, it was. You're absolutely right. I was going to say, I'll pull up this. You can see, yeah, it's still going. So, yeah, it's the wrong one. So I'll just say no IP access group 1 out. And then I'll go interface gigabit 00. There we go. That's it going in. If I go to this laptop here, go to the desktop, go to command prompt, try and ping 192.168.0.2. No, it doesn't work either. If I go to this laptop here, it should work okay. I've got a desktop, command prompt, ping 192.168.0.2. Yeah, and it works okay. If I hadn't have put that permit any, that wouldn't have worked. So you can see that the access control list is blocking these 2, but it's allowing this traffic to go through. So what I'll do is I will just take that back off, just so we don't get mixed up later on with what's happening. No IP access group 1 out, that's it. And if I take away no access list 1, that should be it going. Do a show 1. Yeah, it's gone. Okay, so that's a standard list. Is everybody okay with that one? Like it should have been a little bit of revision, because it sounds like you might have covered it before, but obviously it's important to make sure that everybody's happy with that. So is everybody okay with the standard one? We can move on to an extended. Brilliant. Okay. So I'm going to move on to the extended. Now, the extended has got much more. You've got much more control with an extended. The first thing about an extended is you can supply, instead of just a source address to block, which is the case with a standard, you've only got, on a standard one, you've only got the source address. So that's why it has to be placed nearest the destination. And that is why one of the disadvantages is that traffic has to travel here before it gets blocked. So the good thing about an extended is you can supply a source IP address and a destination IP address. So that means that you can place it on the router that's nearest to where the traffic is coming from. You can also block certain ports. So you can say, well, I want to block this laptop from getting to the web server, and I want to block it on web traffic. So let's say it's just a multi-purpose server and it's got web pages on it. You can say, right, I want to block web access, or you can say, I want to block laptop 10.0.0.2 from getting web access anywhere, because they've been surfacing on the web too much. I want to stop that happening. I want to only give them email access. And so you can do that. You can say, well, block the web traffic, but allow everything else to go through, or only allow email traffic and block everything else. So you can be really quite refined about it. You can block pings, for example. So if you want to stop somebody pinging, you can block FTP traffic. So if you want to just stop FTP from happening on your network, you can do that. And you can do that with a single host. You can do it with an entire network. You can do it with a range of addresses in a network, because you've got the wildcard mask as well, and you make can make the wildcard mask suit. So let's think about how we would achieve the same thing that we were trying to do here, which is blocking access to the server. But let's say, well, let's not block entire access. Let's block their web access, but allow them everything else. And we will do that using an extended access control list. Okay, so if we go into 10.0.0.2 and I go to the web browser, we will just check it's working first before we go ahead and start messing with it. So if I put in 192.168.0.2 into the web browser, I've got a web browser. It's come up. So you can see, yep, definitely the web browser's working. I can click on links. It's working. So this is what we want to block. We want to block that on laptop 0. Just on laptop 0, so we can test it on PC 0, just to make sure that we haven't blocked it inadvertently as well. Let's just try PC 0, make sure it works. I'm assuming it will. But it's worth checking before, because if you try and troubleshoot and then you didn't know if it worked before, you've got no chance. So yeah, that's definitely working. Okay, so we want to block 10.0.0.2 from getting to 192.168.0.2, and we want to block it purely on web traffic. So what we do is we go to the router that's nearest, we go to the port that's nearest, and this time the traffic, it won't be outbound traffic, will it? What kind of traffic will it be coming into that gigabit 00 interface? Where would we place the access control list once we've written it?
Inbound.
Inbound, yeah, absolutely. So, same thing. Let's go into the Glasgow router. Let's go to global config mode. Oh my God, my typing is atrocious. There we go. So what we want to do is web traffic TCP, or is it, yeah, web traffic probably is TCP. Is it contact? Is it connectionless? Because you can block, obviously, protocol, you can block IP, or you can block TCP. I'm just going to block it TCP. So what we're going to do is we're going to make access list 101. Now you can see we're in the hundreds now. So instead of 1, I've put 101, and that will show you that it's an extended. And what I'm going to do is I want to deny TCP from host. Well, I'll tell you what, I'll make it 10.0.0.2, And what I want to do is I want to check every single bit of that IP address. So 0.0.0.0, which means look at all of those. And I want to block it from going to the server, which is 192.168.0.2. And again, check it, check it, check it, check it. Now you see, like, it's on a extended access control list, it's always from to. So you put the from first, where it's coming from, or the source address first, and then you put the destination address second. So the way I always think about it in my head is from to. So it's from 10.0.0.2 going to 192.168.0.2. Now we want to put in EQ. Now you can put in the port number if you like, or there is a number of shorthands. Now web traffic could be classed as www, or you could say port 80. See if you just do a question mark on this, you will see some of the common ones there, like Telnet, SMTP, POP3, FTP are kind of pre-written into little word formats for you, or you can just base it on port number. So I'm going to say EQ80, which is port 80. Oh no, I'll just do www. It's fine. Either or would work. Now, exactly the same as the standard, because we want to allow everything else to work, we only want to block one thing, and that's that laptop getting to there on web traffic, but everything else is fine. So we have to then say access list 101 permit any. What any means is just any source address going to any destination address. And we don't have to supply a port. We don't need to tell it, because it just assumes that it's every port then. We'll put a protocol in. So we'll just say IP, so it covers every protocol, every IP protocol, and that's it. So access list 101, permit IP, any. So it's the IP protocol, any source address going to any destination address. We're going to allow that. So again, nothing's happened yet. We haven't applied it yet. What you can do is you can do a show run. You can see if it's taken it okay. And you can see in the running config, there are our entries there. So it's definitely been programmed okay. So let's apply it now. So we go to interface. It's, I think that was gig 00, wasn't it? Yeah, it's gig 00. And we're on the Glasgow. So interface gig 00. We're going to be access, IP access group 101, and we're going to check the traffic coming inbound on this port here. So that's it now applied. So what I should be able to do is go into this laptop and I won't get a web page. And if I go into this laptop, I will get a web page. So let's go into the laptop, go to web browser, and 192.168.0.2. Nothing's happening. Request timeout. You see that? Let's go to PC 0. Go to web browser. Fingers crossed this one is okay. Straight away, our web page is working. We know it's absolutely fine. But only on 10.0.0.2 are we getting this request timeout. Now, just to check it, let's go back in here. We can put a no in front of that. That turns it back off. And then we can say PC, no, with laptop 0, there we go. Let's try it again. Yeah, it's back on. You see that? So what I'm going to do is I'm going to go back in and I'm going to turn it back on and then just check things like, will a ping work? Which it should do. Okay, 10.0.0.2. Laptop 0. Might have to close it and reopen it. Let's just see. Yeah, it would come up straight away. It's going to come up request timeout. There we go. All good. Let's try a ping on here. Can we ping? Command prompt. So we can't get web access to the server, but we can ping it. We're getting a successful ping going across. So you can see that the extended is a lot more granular. It's got a lot more power to it. You can block certain things and you can block certain ranges or certain IP addresses. And the benefit as well is it's nearest to source. So only unwanted traffic is going to be local. It's not going to go across all these serial links to be blocked there. It's getting blocked at source, which is obviously far better. So that is, sorry, I'm just looking at that. Yeah, that's our extended access control list. Is that okay with everyone? Yep, perfect. Okay. So just remember, if you're using an extended access control list, go from 101 onwards. If you're using a standard, make it between 1 and 99, and automatically the router knows whether you want to create a standard or an extended. Let's look at a named access control list, because having, let's say you had maybe 10 different access control lists for different things. See, just having a number, how would you know which one did what? You would be going, what's that one again? Why did I create that? And you would have no idea just by the number. You'd have to look at what was in the access control list. Then you would have to think, right, okay, that's doing that. So therefore, why not just name it? If you name it, you can obviously give it a meaningful name. So what we're going to do is we're going to block ping from 10.0.0.3 going to the server. And the reason I'm picking the server all the time is just because it's like the furthest away port, furthest away host, and it just, it allows you to see, because there's HTTP on that. You can ping it as well. So if you block one thing, you can check to make sure that only one port has been blocked by checking another port. But you can equally, block access to any PC or any network range if you wanted to. So let's look at a named one, really, really easy. So we're going to block 10.0.0.3 from pinging 192.168.0.2. And again, it's going to be placed on the Glasgow. It's going to be placed nearest to source, so it's going to be that gigabit 00 port again. So back to config. What we do this time is slightly different. IP access list extended, and then you give it a name. Now the name could be anything. I could put Ian in there. But obviously you want to make it something that's meaningful, right? So I'm just going to call it block ping, right? Doesn't have to be capitals either. It can be lowercase, doesn't matter. I've just made it block ping in capital so you can see it. So IP access list extended block ping. Now, can you see the difference? What's happened? When I hit enter, it's bringing me up to config extended named access control list. And I can just put in my commands one by one now. You see the difference, whereas before I would have had to say I would have to say access list 101, deny this, EQ, whatever, and then permit, access list 101, permit. Don't have to do that here. You put in the name, and then you just put in all the commands that you want. So there's not going to be many of them. What we want to say is we want to deny, and this time it's not really TCP, it's not really IP, it's ICMP, because that's where ping belongs to, doesn't it? That's the protocol it belongs to. See if I put a question mark here, you can see the different types here. So you can have AHP, EIGRP, ESP, GRE, ICMP, IP, OSPF, TCP, UDP. The most common ones you'll probably use will be IP, TCP, UDP, and maybe ICMP if you want to block pings. Those will be the common ones. Okay, so we want to deny ICMP. We want to say it's 10.0.0.3. We want to block him, and we want to say match every. So the wildcard mask is matching every digit of the IP address because it's 0000. That's like look at. And then we want to say, where are we blocking it to? We are blocking it to 192.168.0.2. Now, which protocol, or not protocol, but which, we said it's ICMP, but ICMP's got lots of different parts to it. So it's the echo that we want to block. Okay. Oh, made a mistake somewhere. Oh, I forgot my wildcard mask. That's because I was going to show you another way of doing it. Instead of putting all the zeros in, but I'll show you that in a minute. Okay, it's asking then for my next command, and it's just going to be permit IP any. That's us. Yeah, what I was going to show you here was, see, instead of, if it's one particular IP address, you can say, instead of saying 10.0.0.3, then 0000, you can say host 10.0.0.3. And I could have said host 192.168.0.2 instead of doing that, but either or. So that's that now created as well. And we would just have to apply that. So if I exit out, we go to interface, gigabit 0, 0. So IP access group block ping. So you just, instead of saying 1, which was the number 1 or 101 or whatever it was, you just give it the name in this point, and then you just say in, because it's going to be inbound. The data or the packets that we're interested in are coming in to the router. And that's it. It's created. So if I go to PC with 10.0.0.3, I should be able to see that it is blocked. If I go in fact, if I do a ping minus T and I'll go and switch it off, we should be able to see it coming back through. Oh, that's it come back through. And then if I turn it back off again, hit enter. You can see how quick it is. It's just bam, straight away blocked. There's no delay on it at all, really. Okay. So that's essentially, we've covered standard, we've covered extended, and we've covered named IP access lists or access control lists. One last one we've got to do is a bit more uncomfortable because you're dealing with IPv6 addresses. Again, IPv6, there's no big mystery about IPv6. It's just a bit of a pain with the IP addresses because they are longer and much more complex. But before I go on and just do an access control list for IPv6, is everybody okay with the named, well, the standard, the extended, and the named? Does anybody want to ask me anything about that before we move on? Let's grab a wee drink of water while you're thinking. Obviously, access control lists do come up in that practical that I've given you out. I think there's maybe, there's 2 or 3 that you've got to do. So it is important that you've got a good understanding of the access control list, how they work, where they should be applied, and any little kind of wee tips like remembering to put in a permit statement, because if you've got a 1 entry in your access control list and that says deny, then you're denying everything because of that implicit deny any statement that's you don't see, but it's there. So unless you put a permit statement in, everything will be blocked. So just always remember to put a permit any, just to allow any other traffic just to get through. All right, what I'll do is I will have taken these back off. No, I'm going to take this back off here. Oh. Wrong interface. Think about 0.0. No IP access group block. Hang on. Okay. I just wanted to make sure I had everything taken back off. I can't remember the command. Right. I'm just going to double check there's nothing applied. No, nothing on that one. You can see my access control lists are still there. They're still living there, if you like. But they haven't been applied to any interface. You would see on the interface, you would see it would be applied. Okay. So what I've got is I've put some IPv6 addresses on. I've tried to keep them quite simple. And the ones Cisco use quite commonly are like this 2001:DB8:cafe or CAFE : and then they do either 10, 20, 30, and then : 1 will be the router, 2 would be the host, 3 would be another host, and so on, and then /64. So that's the kind of IP address I kind of stick with, just because it makes it more familiar when you come to do the assessment. So on the interface gigabit 00, you can see I've got 10.0.0.1, but I've also got an IPv6 address. Now, in order to give it that IPv6 address, all I did was go into the interface gigabit 00 and then just say, instead of saying IP address, like you would do for IPv4, you just say IPv6 address, and then you give it the address, and instead of a mask, you got a forward slash, and then however many network bits, and it's fairly easy. So on here, I've got that. I've got routing enabled as well. So you can see I've got IPv6 router, OSPF, and I made it 10. And of course, it starts to go out all the ports automatically, and let's just say they're a passive port. So on the Glasgow, I should have an IPv6 address also on gigabit 01, which I have. And can you see? I don't know if you can see that, if it's maybe too small, but when I hover over it, you can see the IPv6 address there. It's for gigabit 01, it's 2001 DB8 cafe 30::1/64. So the gigabit 00 is 10, the gigabit 01 is 30. That's the differentiator between the two. And I've got the laptop set up with an address 10::2 on that one, and I've got this laptop 1 as 30::3. So what I'm going to do is I am going to deny access between, I'm just trying to think. I'm just going to block access from this laptop getting anywhere. And so what we'll do is we'll try and get it to go to the server. No, because it's IPv6. I'm going to get it to ping to here. And then we're going to apply the access control list, and then it shouldn't be able to ping from there. Okay. We'll see there's slight differences in the way that you set up. Essentially, it's the same process. You write the access control list. You've got to add the permit statement again, the same as before, and then you got to apply it to an interface. It's a slightly different terminology to apply it to an interface. It's the same kind of process, just a slightly different syntax, if you like. Okay, so what we're going to do is on the Glasgow router, we're going to create an IPv6 access list to block 30::3 from getting to 10::2 on this one. Okay, so that's going to block that at that point there, and we're going to apply it on the gigabit 01 in an inbound direction. Okay, so let's go into the Glasgow, and let's get writing the. Oh, let's get writing it. So IPv6 access list, and again here, I think you're forced into making it a name. Yeah, see, I put a question mark there. Word user selected string identifying this access list. I'm just going to call it, just to show you can call it N, I'm going to call it Ian, right? And then same as the kind of named access control list that you had on IPv4, it comes up with this kind of prompt, and then you just put it in one by one. So we want to deny IPv6 2001 DB8 cafe 30::3 /64 from going anywhere.
You put BD8 is DB8.
Oh, so I have. Well done. Yeah, DB8. Well spotted. That wouldn't have worked. Okay. So we're denying IPv6 2001 DB8 cafe 30::3 /64 from getting anywhere. So it won't go anywhere. That's fine. What we want to do, is, remember, the implicit deny. So we want to permit IPv6, any. We want to allow any other IPv6 address from getting to any other one. So that's happy with that. And that's it. So again, just to confirm this before and after, I'll do a command prompt. So what I want to do is I want to ping -t 2001 DB8 cafe 30:3 /64. There we go. You don't need the /64. So there we go. It's quite merrily pinging away, no problem at all. So let's go into the Glasgow router and we will apply this to an interface. So we said we wanted it to be gigabit 01. So interface gigabit 01. That's us in. Now this is where it differs slightly. It's not access group that you use for IPv6. They've changed it for some unknown reason. It's now called traffic filter. So you say IPv6 traffic filter, then the name of it, I called it Ian, and then the direction. Okay, so just a slightly different name for the IPv6 one, traffic filter rather than access group, but the same, other than that, same. So IPv6 traffic filter, Ian, in. And that's given us that. And we should see that should have stopped.
Yeah, that's because you're pinging yourself there. But in the 33, and that's the computer.
Oh, so I am. Well done. Well spotted. Sometimes you can get too close to it. Right, I'm just going to take this back off. Laptop 0. Yeah. Yeah. So what I wanted to ping was what was it, 10.2? Yeah. I'm pinging myself. It's actually timing out. Maybe the first one will. No. Definitely did de-apply that, didn't I? No IPv6 traffic filter in. Yeah, something not right. What's stopping that? Let me just double check everything. On the router, I've got 2001 DB8 cafe 10.1. Let me try and ping that first and then see if I can get a reply. Yeah, I'm getting a reply from there. So that's there, isn't it? So let's see what's wrong with the laptop here. Oh, I've made it 10.3. You see that? I badged it as 10.2. It was obviously meant to be 10.2, but I've programmed it as 10.3. Its default gateway is 10.1. Yeah, that's right. So back to laptop 1. This is why you always test it before you apply the filter, because you would have no idea whether it worked or not. Okay, that's happily pinging away there. So I am on 30::3, which is this laptop here. It's going up and it's pinging 10::2, which is this laptop here. You can see there 10::2. I'm going to now go in. I'll put the two of them up at the same time so you can see it's slightly slower with IPv6, and I don't know why. Oh no, straight away. It must have been a glitch they had in Packet Tracer previously, because I remember thinking, why is it much slower? But no, that was straight away there. So if I say no, hit enter, then it's back. Apply the filter again, or apply the access control list. That's it, blocked. So for IPv6, it's kind of like a named access control list. It's what it's most like. You do have the ability to block from and to, so it's like an extended, it goes nearest the source. And you've got the ability to block certain things like ports as well, if you wanted to. The only real difference is obviously you have to use the IPv6 command, and when you apply it, you have to use IPv6 traffic filter rather than access group. But other than that, you put the name of the group that you want applied, or the access list applied, and then you tell it a direction, and that's it. What I'm going to do is I'm going to just de-apply that, because I'm going to share this with you. I'm going to put it on the team just so that you can take it and do what I was doing, just have a play about with it. I think that's the best way, to try and use access control lists, is just to play about with them and just get a feel for it, and just do similar to what I've done. Just try and ping it, apply it, ping it again. Does it work? Or if you're going to block web access, can you get web access? No. Then obviously, try it. So the main things to remember are standard access control list can only block on source address, so therefore it has to be placed nearest the destination, because that's the only place it can go. If you were to block the source address here, that would block that source from getting anywhere. So it has to be nearest the destination. Obviously, access control, some standard ones, they don't have as much. I'm just trying to think of a way where you would use it. Long short of it, they probably take up less router resources in terms of what it has to check, because it doesn't have to check the from and the to, and it doesn't have to go into the packet and look at the protocol being used and such like. So it's probably uses less overhead, but really limited in its use. The extended access control list is much more powerful in terms of what you can do and the things you can block. You can block whole networks, you can block parts of networks, you can block single hosts from going to a particular network or a particular host as well. So depending on how you use your wildcard mask, you can block ranges or single addresses. The named one obviously makes it much more easy to understand what it was for. So when you look back, or if you look back on somebody else's config, you can tell what they meant by it. And obviously an IPv6 is very much like a named IPv4 address, except you're dealing with IPv6 addresses. And the way of applying it is similar, but it's a different name that you use. Instead of access group, you use traffic filter. So in terms of IP access control lists, that's pretty much it. You will have to configure them for the practical, but that's essentially it. Does anybody want to ask me anything just before we kind of move on to the next bit?
See, if you blocked an IPv6 ping, Would that
Yes.
also block the IPv4 ping?
No.
So you would still be able to contact it through IPv4?
Yeah, you would. It's just because an extended or a named IPv4 looks at IPv4 addresses, whereas an IPv6 only looks at IPv6. And so if you wanted to block ping for both, you would have to use both. So there is a whole load of slides on that, and essentially the slides just cover exactly what I've covered. Other things, I'm just flicking through them just to make sure I haven't missed anything. You're only allowed one access list per protocol. And you're only allowed one access list per direction, and you're only allowed one access list per interface. So you can have, if you had an access list here and it was inbound, you couldn't have two of them go looking at inbound. It's one. If you want to have more than that, you need to think about, if you wanted to block two different kinds of things, put them into the one access control list. Don't have multiple access control lists trying to control that, because it won't allow you to have multiple access control lists going in one direction. So if you try to write access control list 101 and then access control list 102, and you try to place them on the Glasgow 00 inbound, it wouldn't allow you to. So just make your access control list complex enough so that it covers everything you need to do, and you've got one access control list per direction. Okay. There is a slide on that. It does tell you that. It tells you as well how it goes through the list. Obviously, you want to make it, in terms of efficiency, you want to put the statements that are the most general, so the ones that will get hit most, you want to put them higher up the list, and running down your list to the most specific. So just in terms of writing your access control list, if you're writing it with multiple lines on it, make the top one the most general, the one that's going to catch the most, and run it down to the most specific. You don't want to make your most specific the top, because less things will get hit by that, and it just causes delays. So make it the one that's going to generate the most hits, if you like, or the most matches. Put it at the top, the one that's most general at the top. Flicking through, yeah, I think I've covered pretty much all of that. How to place it, what the structure is. There are lots of labs in there if you wanted to go through the labs as well, or if you wanted to use mine as an example as well. IPv6, yeah, I've covered that. Troubleshooting, essentially troubleshooting, the best thing you can do is make sure that everything, just like I did, make sure everything worked before you apply it. Because see if you can't get access before you apply it, and you've got to apply it, and you don't know if it's working or not, basically. So make sure that beforehand you try it, and then apply it, then see if you don't get access. Just think logically about it. Obviously, it's a logical thing. You can look at show access lists, and that will show you what access lists you've got, but it will also show you what they contain and what order they're going to be processed in. But again, it's the most generic down to the most specific is the way you would want to do it. Just looking at common errors, just looking at some of the stuff in here. It's direction. That's one of the big ones as well. That's why I said think about as if when you're creating your access control list, imagine yourself inside the router. Imagine you're sitting inside the router typing. That's what I try and do when I'm doing it. And then you always get it right. But when you think about what you're trying to block and which direction, if you're placing yourself inside the router and you're looking at packets coming into you, then that's inbound. If you're sitting in the router and you're looking at packets going out from you, the router, then that would be an outbound direction. So think about inbound and outbound, but imagine yourself, you're sitting inside the router and you're looking at traffic either coming in or getting pushed out of that port. Probably won't go far wrong. I'm just double checking. Yeah, common errors, we've kind of covered that. Again, with the standard and extended place it closest to the source of where the traffic's coming from. So that would be, if it was for the laptop, that would be here. For an extended, place it nearest to the destination of where you're going. So the nearest to the destination for a standard would be nearest router port to wherever you're trying to go, and it would be on the outbound direction mostly for that. Yep, I've pretty much covered all of that. I'm just going to show you some slides just based on the LAN security. So in terms of access control lists, they are one way of protecting your network. So I'm just going to pop these up. There's a few slides on this. Take 10 minutes to go through these, and then I'll go through the assignment in terms of the practical and just kind of give you a wee rundown about that as well. So slideshow from current slide. Okay, so common security, obviously routers and switches can be used as part of a security solution in your network. They can be used, in conjunction with intrusion protection systems, firewalls, VPNs, just to make sure you've got full coverage from layer 3 up through to layer 7. Layer 2 obviously has got to be protected. And layer 2 attacks, you could have a CDP reconnaissance attack. That's a Cisco discovery protocol. So they can be those kind of frames going back and forward that the routers and switches use to talk to each other. That can be used to form a reconnaissance attack. Telnet attacks, you kind of get a MAC address table flooding attack where you flood the switch with new MAC addresses and it ends up filling the MAC address and it causes overflow errors, and that can obviously be a way in. There's obviously VLAN attacks and DHCP attacks that can occur as well. So we'll look at these. So the Cisco discovery protocol, basically what it's used for, it's used by routers and switches to talk to each other on a network and automatically discover each other. But that information that's flying back and forward can be used by an attacker. If you want to turn CDP off, you can use no CDP run, and that will disable CDP globally on that device. Or you can use no CDP enable if you want to just enable disable, because it's no CDP enable on an interface, just to turn it off of that particular interface. So it might be you've got an internal network, but you've got one that's facing outwardly. So you might want to turn it off on that one to prevent any attacks coming in. Telnet attacks, two types of telnet. Obviously, telnet's not used as much now, but it's still used in a lot of situations, so you've got to be aware of it. A brute force password attack is a way you can try and get in, just like a dictionary, a trial and error method to try and get the admin password. Or you could try a denial of service, just continuously request telnet connections and hoping that you'll render the telnet service unavailable. So to mitigate those attacks, don't use telnet, use SSH instead. Use strong passwords that are changed regularly to help prevent against a brute force attack. You can limit access to your VTY lines using an access control list. And you can use AAA, so either TACACS or Radius, to provide authentication for that. The MAC address flooding attack, that's the one where basically you try and flood a switch with fake MAC addresses. And what you're hoping to do is to fill up the table and overfill the switch and make the switch fall over into a fail open mode. And then it starts broadcasting all frames. And then the attacker starts to capture those frames and gets a picture of what's going on in the network. And, you know, it can cause a bit of problem. Port security. So did we cover port security? I can't remember. It's where you would use maybe like a MAC address sticky. So it would remember the MAC address that's on that port, and it wouldn't allow any more, or it allows a max of 3 addresses per port. Then an administrator would have to come in and reset it if there was more than 3, for example. So that's a way it could be done. Or you could force the MAC address to be learned, and once it's learned, that one stays. Again, these have got an administrative overhead. You've got to weigh up the security against how much you want your work to prevent that. Spoofing attack, that's an example of a kind of VLAN attack. So an attacker would gain access to a VLAN by spoofing. So it says here, attacker can gain VLAN access by configuring a host to spoof a switch and use the trunking protocol and DTP to trunk with the connecting switch. So it's basically created an unauthorized trunk, and then you're into the VLAN. So how to mitigate it? Configure your access links. So put down manually on your switch which ones you want to be trunk and which ones you want to have access. If you made that port an access port, manually, it can never become a trunk port. So that would prevent that from happening. You can also disable auto trunking. You can manually enable the trunk lines as well. So you can say, right, okay, well, that is a trunk line, but the rest are access lines. And so therefore you can't trunk. Disable any unused ports to make them access ports, and assign them to like a black hole VLAN, a VLAN that, call it, VLAN 32. Nobody's on VLAN 32. So all they're going to get is access to VLAN 32 where nothing is on. Change your default native VLAN, usually 99, change it to something else, because everybody knows VLAN 99 is the native VLAN. And again, port security would have stopped that as well. DHCP spoofing can happen when an attacker configures a fake DHCP server and starts to issue IP addresses to clients. Then the attacker will flood the DHCP server with the proper legitimate DHCP server with bogus DHCP requests. It results in all the IP addresses being given out, and it results into denial of service because new clients can't obtain an IP address. So you can configure DHCP snooping on the routers and switches, and you can configure port security as well, and these two things can stop DHCP attacks from happening. Basically, you want to try and secure your LAN. So if you're looking at layer 2 of a network, you can use SSH, so a telnet, you can use SCP, you can use SSL. All of these things will help mitigate layer 2 attacks. Use strong passwords, change them often, enable CDP on the ports that you want to have. Don't put them on them all by default. Secure your telnet access or use SSH instead. Use a dedicated management VLAN. Don't leave it as the native. And use access control lists, which we've just seen, to filter unwanted access. So, port security, DHCP snooping, dynamic ARP inspection prevents ARP spoofing and poisoning that can happen with ARP attacks, and IP source guard that you can get on some devices helps prevent MAC and IP address spoofing as well. So a whole kind of pyramid of things that you can use at layer 2 to help secure your network. Mitigate MAC address flooding, enable port security. It allows a basic administrator to say, this is the MAC address for that port, or you can get it to dynamically learn a limited amount. That was the sticky one I was telling you about. So it will learn so many, maybe up to 3. And if it learns any more than 3, it has to have an admin to reset it. It says when the maximum addresses is reached, any additional attempts to connect by an unknown MAC address will generate a security violation. Because you would think that in a stable network, that the machine plugged into the wall is the machine plugged into the wall. It's not going to change that often. So maybe having 3 addresses would be fine. Mitigate VLAN attacks, disable DTP and set interfaces to access mode. We kind of covered this, but you would use switch port mode access to make a switch port access. You would set switch port mode trunk for any ones that you did want to have as trunk, and disable the auto trunking and put switch port no negotiate, and change the native VLAN from VLAN 1 or whatever to something else. DHCP attacks use DHCP snooping. So with snooping enabled on an interface, the switch will deny packets that contain an unauthorized DHCP server coming from an untrusted port, because your DHCP server should come from a trusted port. If you're getting your DHCP through a different port, that's not the one you would expect to see it coming from, and so that kind of helps overcome that. So only ports connecting to upstream DHCP servers should be trusted, and the untrusted ones should not be providing DHCP server messages to users. So that helps mitigate that. Using AAA, it's just basically your authentication, isn't it? So we've got simple AAA on the router. You've got the username and password. It's got a database on the router, or you can combine it to AttackAxe or a Radius server that will pass the messages on and authenticate you, and then give you access to the router that way. So it's making it more secure. Using 802.1x, basically you can restrict unauthorized workstations from connecting to a LAN. They would have to authenticate each workstation to connect to the switch before making any services available. So if somebody does come in, unplug, and plug in their own device into your network, they'll only be allowed access if they, are authenticated, and there'll be an authentication server that will perform the client authentication, and then obviously the switch will give control to the network based on the client authentication status. So a lot of security options in there. Okay, so basically we covered access control lists. By default, a router won't filter traffic. Traffic that enters a router is routed solely based on the routing table. So the access control list, essentially, it's just a list of permit or deny statements. The last statement of an access control list, remember, is always that implicit deny, which will block all traffic. To prevent the implied deny any statement at the end, use permit IP any to allow any other traffic to go through. So when network traffic passes through each interface configured with an access control list, the router will compare the information in the packet against each entry of the access control list in a sequential order to determine if the packet matches one of the statements. As soon as a match is found, whether that's a permit or a deny, that's processed accordingly, and it will either be chucked in the bin or it will be forwarded on. They can be applied inbound or outbound, and standard can be used to permit or deny traffic only from a source address. So basically, you have to place it closest to the destination as you can. For extended, they filter packets based on source address, destination, protocol type, and source or destination ports as well. The basic rule for placing an extended is to place it as close to the source as possible. The access list global config will allow you to put it in. You can create a named standard or a named extended, just to give you a name. But 1 to 99 is your standard. After your access control list is configured, you apply it to the interface with the IP access group command. If you want to remove it, as you've seen me doing, you put no IP access group and then whatever number or name it was to place it. If you want to remove the access list altogether, you would say no access list 1 or no access list 101 or no access list Ian or whatever you've called it or whatever number it has, and that removes the entire ACL from your router. And I'll do that. I'll quickly do that before I upload my configuration to the team so that you can have a play about with it. Show running config will show you your access control list, as will show access lists as well. And the show interface command will verify the ACL on the interface and which direction it was applied and that kind of thing. The access class command configured in the line config mode is used to link an ACL to a VTY. So you would use that to apply an access control list to a telnet line, a VTY line. From global config mode, you use IPv6 access list name command to create an IPv6 named access control list. It doesn't use wildcard masks. Instead, it uses the prefix length to indicate how much of a source or destination address should be matched. After an IPv6 ACL is configured, it's linked using the IPv6 traffic filter command. IPv6 doesn't have standard or extended, it's just the kind of extended version that it's got. Okay, that's us. Does anybody want to ask me any questions on that before we quickly take a 5-minute look at the practical? Just while you're doing that, I'm just going to go in and remove the access lists that I have. So I've got 101, I've got block ping, and I've got Ian. So no IP, no access list 101. Access lists block ping. Oh, have I got one called block ping? Yeah. Right, the practical is due. Let's have a quick look at the team because I did update in here. File. Oh, where am I? Go to Teams. I'm just going into our, no, that's the evening class one. Come on, Ian. There we go. Internetworking. Class schedule, here we go. Okay, so you can see last week I've updated it with Strike Action. This week, IPv6, well, it's IPv4 and IPv6 ACLs from Chapter 4, Network Security from Chapter 5, Packet Tracer assessment made available. The deadline is the 19th of May. I can probably, I would say the 19th, yeah. I'm just trying to see what day that was. It's a Wednesday. I could probably go right up until the 23rd, realistically, before I start pulling it together. So, but I would still say the 19th. That should give you plenty of time. Well, when am I going to finish? Yeah, still gives you plenty of time. I'm going to go through the revision and the tutorial towards completing the packet tracer assessment on the 11th. That still gives you 8 days to then go ahead and complete it. It will take you a couple of hours at most to go through it. So yeah, 19th of May is the short answer to that one. So let me just have a quick look and show you the practical then. Obviously it's in your assignments area. Where's final packet tracer. Okay, so when you open up the assessment, what you will see is you will see this setup here. You will also have a set of instructions that look like this. Now, this set of instructions, I think I've got on the team. If not, I'll put it up on the team, just so you can see a paper version of it as well. But you can see in here, in this practical skills assessment, you're given this topology, but it's blank. It's been kind of created, but it's essentially blank. Anything that's needing to be set up has been set up. But read the instructions, carry them out in the order that they're given, and once you reach 100%, then you've finished, and you can submit your saved completed file back up into the assignment area. Essentially, you're going to be configuring PPP with CHAP. You're going to configure access lists to limit network access. You're going to use an access control list to determine the IP addresses that are going to be allowed to use network address translation. You're going to also configure a GRE tunnel to allow BGP updates between the east and the west. So effectively, you're going to create a tunnel across here, router 1 to router 3. It says you're also going to configure SNMP and SPAN for network monitoring. I've taken that bit out because it doesn't work in Packet Tracer. So just ignore that bit about SNMP and SPAN. I've actually taken that section out. It says network configurations and connectivity will be verified throughout, because you'll be able to see and check your results so you can see where you're at. So first step, configure the PCs. So obviously it's dead easy. You just go in. If I start configuring the PCs, PCA, for example, put in the IP address, and it's 192. You can see obviously why this is better if you've got a dual screen setup, or if you've got these instructions on paper. So 192.168.110, 192.168.1.10, subnet mask default gateway is 192.168.1.1. It's also got an IPv6 address, and that's 2001, very similar to the ones I was using. DB8, ACAD, 1, and then 64. So you can see as I'm going through and completing that, you can see the completion is going up.
Sorry, Ian, is this the assessment you're doing right now?
Yes.
Okay.
Yeah, but at this point, it shows that the link local address is wrong.
Was that, sorry?
It shows on the results that the link local address is wrong on PCA and PCB.
Does it?
Yeah.
I'll just double check that.
When I was doing it.
All right, okay, let me have a quick look. So IP, so PC, which one did you say there? Sorry, PCB.
On both, when you check, when I check the results, it shows me that on both PCs the link local is wrong, incorrect.
Right. Okay. Let's have a look at the check results. Because what it's taken is I had obviously gone through it, started with the blank one, made that my start point. I then went through and coded it all and completed it all and got to an end point, saved it, and the differences between the start point and the end point, that's what it's looking for. Let's look at check results. That looks okay. I haven't put the default gateway in yet. I haven't put the link local in yet. But that looks okay. Let me just go and put the default gateway in, and I'll put the link local in, and we'll see where we're at. But it should be. Oh, right, hold on, I'll close this. Right, let me have a quick PCA, IP configuration, put the instructions back up. All righty. IPv6 default gateway, FE80, column 1. What else have I missed? Is that it? Link local. Is that what's maybe wrong? The link local?
Yes, link local, it shows incorrect.
Right, that's. All right, let's have a look. See if I can see what it's looking for. Check results. Assessment items, link local, yeah. So does it say, because the link local, it's taking the default one, isn't it? It doesn't give you a link local there. What I will do is I will just have a quick look and see what it's looking for. FE80 colon 1 is link local. So let me just so the link local basically is FE80 colon 1, the same as the default gateway. That wasn't clear.
Thank you.
Did you want to try and put it in and see if it gives you the result for it?
No.
I'm just going to open it back up again. Let's see if I can get it. It should really be in the instructions. Although maybe there is a summary at the end. Is there a summary at the end that shows you all the ports and what they should be? No. Okay. What I'll do is PCA, desktop IP configuration, link local, FE80 colon 1. Oh. FE80 colon 1. FE80 colon 1. Let's see if that. Should be fine. There we go. Check the results. Yeah, it's come up. Yeah, link local. Yeah. So whatever the default gateway is for IPv6, that's the link local address.
Thank you very much.
All right. So like I say, we will go through this. But if you want to have a stab at it, you want to have a go at some of the stuff, and obviously you're welcome to, and you can have a wee go. Problem comes if you're not sure what you're doing and you make a mistake on something and you change something, or you know, you delete something or something, you know, you will never get to 100. However, what you can do obviously is just re-download it from the assignments area and start again, or reset the activity. Okay, so this is where we're at now. So the packet tracer assessment has been made available just really for your own reference, so you can see what kind of things you're going to be doing. It's probably I would say it's far too early unless you've read all 6 chapters for you to be able to have a stab at it, but it just allows you to see what you're up against. So there will be a multiple choice, which is the semester 4 final, and there will be this. That's it. There's no other assessments. One multiple choice exam, which is the final from semester 4, and this. That's it. So, pardon me, next week we are going to be looking at SNMP. Now, SNMP is an important topic. However, because Packet Tracer doesn't work properly in Packet Tracer, it will be one of those ones where you don't really need to know it for the assessment. And we're going to cover chapter 6 as well, so SNMP won't be big, and I won't say I'm going to skim over it. We will cover it, but we don't need to worry too much about the commands. We're also going to cover chapter 6 next week, and that basically allows us to finish everything that we need. The following week, I will go through a revision, just basically everything that we've done, and I'm going to do a tutorial based on completing the Packet Tracer assessment. Probably take it to about the halfway point, because there is a lot in it. So probably show you the commands and the things you need to be aware of, parts 1 to 4, and then the following week I will do some more tailored revision, because you're going to be doing the practice final. So some tailored revision based on, you know, completing the practice final. Once I see the results, I can then see where, you know, what we're missing out on, and I'll do a bit more targeted revision, and then I'll complete the packet tracer revision. And then we can do the final the week after that, which is the 25th, and that's when roughly the packet tracer's due to be back as well. Does that sound okay? Good. Liam, sorry, I just noticed in your question there, you said the practical due. You've done all the chapter exams, so you need to do the final. You would need to do the final as well. So the final and the practical are the two things that we need to do. Like I say, if you want to have a play about with the packet tracer, the final, you know, the kind of practical one, see how you get on. Obviously, it keeps your score, so you'll know where you're at. But if there's nothing else, that's all for me today. And remember, you've got Alan in an hour, so I'll allow you to go and get a bite to eat and prepare for that.
Thank you.
All right.